Hey class, this is Math Unit 2, Lesson 1 and 5/10, or also known as 1 and 1/2, also known as 1.5. But we prefer to say 1 and 5/10 because that's the mathematician's way. And we're going to continue with estimating decimals, then adding or subtracting after we estimate. We might also notice that the estimation after we add or subtract is really close to an exact amount. We can compare those. So let's get started. Here we have 67 and 5/10 plus 15 and 1/10. Now, we first have to decide which place value we want to estimate. I always find that when we're working with decimals, it's nice to estimate to the ones place. That way, we can take the decimal and use it to estimate. Because I'd like using the decimals when they're there. It'll give us a result of an accurate answer while still estimating. So, we know that 5 and above, give it a shove up. Right? After all, that 5 in the 10th place is the equivalent of 5/10. We don't have 10/10 to bundle and move, but 5 is like the middle zone. It's the cutoff. It tells us we can push it up. All right, so that whole thing will now become 68. And I think by now you're realizing that when I estimate, I don't have to use the rest of the numbers. I don't have to write 68.5 now. No, we've already used that, so we're not going to continue with it. Right, now let's do the other part. So we're going to add 68 with 15 and 1/10. Now, of course, that 15 and 1/10, that's only got 1/10. We would need 9 more to bundle it and move it. That's not nearly enough to bundle and move. So we're going to keep it. We're going to keep it at 15. And do we have to include the tenths any longer? Nope. That's right, we don't. All right, so now we could add any variety of ways. How would you add 68 plus 15? Would you prefer the good old-fashioned way? We call this the standard algorithm. When we match up our 10s and our 1s, and then we just simply add them kind of like vertically. We just count and put the answers down here. That always works. But we could add in totally different ways too. Here's something, for example. So what if we put 2 more onto 68 to make 70? Right, think about this. If I were to add 2, that would give me 70, right? Could I easily add 15 onto 70? I could. In my head, I can definitely do that. That's just 10 and 5. So 70 plus 10 is 80, plus 5 more is 85. All right. So if 70 plus 15 is 85, what do I have to do at the very end with the 85? I'm not done. I added 2 up here. So I have to take those 2 away real quick. That's fine, I can easily do that. 85 take away 2, 83. Let's see if it works out here. 8 plus 5 more is 13. Oops, so far it looks good. 3 in the ones place. 6 plus 1 is 7, plus another is 8. 83. Good. Now we're back with the original problem. And we know that our answer when we estimated was 83. So I'm going to pop that down there just so that we can remember it And now let's see if we can come up with an exact answer that's close to 83. That way we'll know for sure that our estimate was accurate. It's close. So in order to do that, we have to line up everything. We're going to stack this the normal way, the standard algorithm way. 67 and 5/10 plus 15 and 1/10. Now, the last step that I have to do when I'm talking about decimals is I must include the decimal in the same place in my answer. Notice how I just lowered an imaginary line and put the decimal right there. Very important. All right, 5 and 1 is 6. All right, from here on out, we've got it. 6/10. 7 and 5 is 12 ones. 7 plus 8. 82 and 6/10. Oh! Well, that is about 83. Especially if we were to round it to the nearest whole number. Yeah, 6 is higher than 5. That would become 83. This is all you are doing today in Big Ideas Math. In fact, you only have to give one answer. You don't have to show it, adding it the standard way, standard algorithm, and this other way that I showed you when I added the 2 extra to make 70. You don't have to do all of that. You just have to estimate, and then the next step would be to either add, which I just showed you to do, or you might be asked to find the difference, in which you would subtract. That's it. Good luck.